Quadratic equations are written in the form ax squared plus bx plus c equals 0, and the graph is a parabola. This is different from linear equations written in the form ax plus b equals 0 with a graph that's a straight line. Quadratic functions in the form ax squared plus bx plus c, their graphs are parabolas. The parabola is this U shape that you see here. If the a value is positive, the parabola opens up. If the a value is negative, the parabola opens down. The vertex is the highest or lowest point on that parabola. The axis of symmetry is a vertical line that can be drawn through the vertex. Parabolas have perfect symmetry. Now the specifics of the graph are as follows. The graph of y equals a times x minus h squared plus k, which is just another way to write y equals ax squared plus bx plus c, is a parabola that opens up if a is positive and opens down if a is negative. The vertex has the ordered pair hk, which can be seen in the vertex form of the equation. The vertex has an x-coordinate of negative b divided by 2a, and the y-coordinate is found by evaluating the equation at the x-coordinate of the vertex. In other words, find the x-coordinate and plug that x value back into the function to find the corresponding y value. To put that all together in a graph, these graphs have the same meaning. The only difference is the a value on the left is positive, so it opens up. The a value on the right is negative, so it opens down. Also penciled in here is the axis of symmetry, which has an equation x equals h, where h is your x value of the vertex. So on the left, for a parabola that opens up, the vertex is the lowest point on the graph. On the right, the vertex is the highest point on the graph. The vertex is a very special point and has a very special meaning. As I mentioned before, the vertex can be found, or the x-coordinate of the vertex can be found by negative b divided by 2a, and the y-coordinate can be found by plugging that x value back into the function. When a quadratic function is in the form f of x equals a times x minus h squared plus k, this is said to be the vertex form. It's the vertex form because the hk is the vertex. It's right there in the formula. There's no need to use the formula for finding vertex because the hk, or the vertex, can be plucked right out of the function in the vertex form. For example, f of x equals x minus 3 squared plus 5. It has a vertex of 3, 5. Given the equation f of x equals x minus 1 squared minus 4, this is in vertex form. The standard form of this exact same equation, which you could find by squaring the x minus 1 using the FOIL method and combining like terms. You could find the standard form, which is f of x equals x squared minus 2x minus 3. While it's in vertex form, we can pluck the vertex out of there, which is 1, negative 4. The axis of symmetry is the vertical line that passes through the vertex, which has the equation x equals h. And in this case, the h is 1, so our axis of symmetry is x equals 1. If we were to find the discriminant of this, we would find that the discriminant is positive, and it gives us 2 real roots. Therefore, the x-intercepts are negative 1 and 3. If we were to take the equation f of x equals x squared minus 2x minus 3 and set it equal to 0, we would find the x-intercepts, which are negative 1 and 3. So this is a parabola that opens up because the a value is positive. The vertex is the lowest point on the graph, meaning that this parabola has a minimum, or this equation has a minimum. Knowing that the vertex is given by this formula, the vertex at its highest point is said to be the maximum, and the vertex at the lowest point is said to be the minimum. So for a parabola that opens down, that vertex is the highest point, making it a maximum. And for a parabola that opens up, that vertex is at the bottom, making it a minimum. If we're given just an equation, so given f of x equals negative 3x squared plus 12x minus 1, we could find whether it has a maximum or minimum value and what that value is. Since the a value is negative, we know that this parabola will open down, therefore having a maximum. We use the formula of x equals negative b divided by 2a, plugging in the b of 12 and the a of negative 3. That's going to give us negative 12 divided by 2 times negative 3, or negative 12 divided by negative 6, which is 2. So we have an x value of 2. This is the x value of our maximum. We then take that 2 and plug it back into the function. So we have negative 3 times 2 squared plus 12 times 2 minus 1. Order of operations is you have to deal with the exponent first. So we have 2 squared, which is 4, times negative 3, which is negative 12, plus 12 times 2, or 24, minus 1, which simplifies to 11. Therefore, the maximum of this function is 11, and it occurs when x equals 2. So the vertex is 2, 11, and it is in fact a maximum.